its primary source of energy is free fatty acids. 67% of the total energy is produced by free fatty acids. Other tissues, most other tissues of the body, they use carbohydrate sources. Heart is an exception. Glucose is used by the heart. Some 30% energy will be derived from glucose. So that's a unique feature of the heart and coronary circulation. And last point is economy of the myocardium. What is the best economy for the heart and myocardium? What is the worst economy? First of all, what is an economy? You see, economy means it's the ratio of work output per unit O2 consumed. That ratio is called as the economy of the heart. I mean, if O2 consumption goes on increasing due to some mechanism, economy will suffer. It will be a bad economy. So let's see good to bad economies. Best economy of the myocardium is when there is increased stroke volume and decreased heart rate, because then oxygen consumption is decreased when the heart rate decreases, and oxygen consumption decreases and at the same time work output increases. Second best, normal, will be when there is a normal stroke volume and a normal heart rate. That's a normal economy. Now, bad economy is when any stroke volume with an increased heart rate. That's a bad economy, because with increased heart rate, oxygen consumption increases proportionately. As the heart rate goes on increasing, oxygen consumption goes on increasing proportionately. So denominator increases, economy suffers. And what is the worst economy of the myocardium? Worst economy of the myocardium is when any cardiac output maintained against increase after load. That's the worst economy of the myocardium. Any cardiac output, if it has to be maintained against an increase after load. In that case, work output will suffer and oxygen consumption will go on increasing. That's poor economy. So that's some of the aspects of coronary circulation. Let's finally see some environmental aspects and exercise. Miscellaneous topics in cardiovascular system. Let's see the effect of gravity, for example. There was an MCQ. Readout results from what? Positive G, 0 G, G is gravity of course, negative G or high barometric pressure. Readout occurs from negative G. Blackout occurs from positive G. What is readout? And when does that happen? First of all, blackout is when person faints. First he sees black and then faints. This occurs from a positive G, positive gravity, because blood is pooled in the lower extremities, lower limbs. So venous return to right side of the heart will decrease, and blood flow to the upper parts of the body will also decrease. Cerebral blood flow will decrease, and the person will faint. That's a blackout. What is readout? Readout will result from negative G. More and more blood sucked towards right side of the heart, more blood coming to heart and more blood coming to upper parts of the body. So cerebral vessels will be engorged with blood, retinal vessels will engorge with blood, and that will lead to fainting, and that's called as readout. Retina, the person is red because retinal vessels were engorged. That's negative and positive G. Let us see the cardiovascular changes during exercise. Very often we are asked what are the cardiovascular changes during different types of exercises. There was an MCQ like this. In isometric exercise, which of the following will not increase? Will not increase which of the following in isometric exercise? And the options are heart rate, cardiac output, mean arterial pressure, and peripheral resistance or systemic vascular resistance. This has been asked previously. Let's try to understand the cardiovascular changes during exercise. Let's first understand the exercises. There are two types of exercises. One is called as isotonic exercise, the other one is isometric exercise. If you remember our discussion on muscle, there are two types of muscle contractions, isometric contraction and isotonic contraction. And isometric contraction means sustained, tension developed, but there is no shortening of the muscle, no change of length remaining the same. That's isometric. So length remaining the same, no shortening of the muscle. That means the other thing that happens in the contraction is tension developed. And isotonic contraction means after a tension is developed, that tension will remain the same and the muscle will shorten. So muscle shortening occurs in isotonic exercise, and it's called as dynamic exercise. So all the cycling, running, jogging, swimming, aerobics types of exercises, they are all isotonic exercises. Isometric means only sustained tension development without shortening of the muscle. So these exercises are also called as static exercises. Therefore, in this category, we have the pulley and the weight exercise, weights lifting and power lifting. Because you see pulley, for example, you pull the pulley down and hold it. There is a sustained tension development in the group of muscles without shortening. There is no shortening, only sustained tension development. So such exercises will be isometric or static exercises. Let's look at the changes one by one. Isotonic exercise. Isotonic exercise, these are the changes. There will be increased heart rate, increased stroke volume, and therefore increased cardiac output. Stroke volume, heart rate increases, therefore cardiac output increases. This is because of increased sympathetic discharge, increased sympathetic drive. So this will be the result. Let us see the effect on blood pressure. How the blood pressure responds in the case of isotonic exercises. We can show it with the help of a graph actually, so that we can remember it for a longer time. Graph will give you a visual. Blood pressure and time into exercise. The change will be like this. Systolic BP increases and diastolic BP will slightly decrease. That's a change with exercise, and therefore pulse pressure widens. The difference between the two will widen. Yeah, this is the systolic blood pressure slightly increases, or rather it increases, but diastolic BP will fall. Systolic BP will increase because of increased sympathetic discharge, increased sympathetic drive. What is the reason of fall of blood pressure? Let's try to understand this. You see, fall of blood pressure occurs because of the muscle chemoreflex. Muscle chemoreflex. That's the reason. The exercising muscles they will release certain chemicals like CO2, H plus, lactic acid, and we've already seen that these chemicals are vasodilators. So they will cause local vasodilation. There would be dilation produced locally in the skeletal muscle. So skeletal muscle blood vessels are dilated. If the skeletal muscle blood vessels are dilated, that means there will be a decrease in peripheral resistance. Remember, which vascular bed is the greatest contributor to the peripheral resistance? The skeletal muscle blood vessels. They are the greatest contributors to the peripheral resistance. So if those blood vessels are dilated locally because of production of those metabolites, the peripheral resistance will decrease. And if the peripheral resistance decreases, which blood pressure is indicated by peripheral resistance? It is the diastolic blood pressure. So diastolic blood pressure decreases. And therefore, these exercises are advised in hypertensive individuals. Hypertensives are advised these exercises because hypertension is labeled on the basis of diastolic blood pressure. So if the diastolic blood pressure decreases, it's good in these exercises. Right, these are the changes in isotonic exercises. Now let's see the isometric exercise. We have already this one MCQ to deal with. What happens in isometric exercise? Which of the following will not increase? In isometric exercise, as we will see, they are contraindicated in hypertensives. Isotonic are advised, the dynamic exercises are advised, isometric are contraindicated. See why? In isometric exercise, like pulley and weights, there is a sustained tension development. Try to understand the difference. In isotonic or dynamic exercise, there was alternate rhythmic contraction and relaxation of the muscle. Alternate rhythmic contraction and relaxation in the agonist and antagonist. That's how isotonic exercise works. Isometric exercise means a sustained tension development. That means muscle is not going to relax. In the isotonic exercise, the muscle was going to relax. Therefore, the blood vessel was going to open up. It was allowed to open up, and there was vasodilation in the skeletal muscle. Here, there is sustained tension development in a group of muscles. So what happens is there is a sustained compression of the blood vessels within the skeletal muscle. Sustained compression of vessels inside those skeletal muscle groups which are contracting in a sustained way. And if there is sustained compression of the vessels, there would be increased peripheral resistance. Increased peripheral resistance. And if there is increased peripheral resistance, that means there would be increased diastolic blood pressure. So skeletal muscle blood vessels are the major contributors to peripheral resistance. If they are compressed in a sustained way, peripheral resistance will increase, vascular resistance increases, diastolic BP increases. Therefore, these exercises are contraindicated in hypertensives, generally speaking. Now, what was the formula for mean arterial pressure? Mean arterial pressure is diastolic BP plus 1/3 of pulse pressure. So if diastolic BP increases, mean arterial pressure will also increase. So here we go. The MCQ was isometric exercise. Which of the following will not increase? These will increase. Diastolic BP increases, mean arterial pressure increases, vascular resistance also increases. That's left with only two choices now: heart rate and cardiac output. Well, heart rate also increases. So the answer to this MCQ was cardiac output. This is for the sake of MCQ, we are selecting the single best response, and that's cardiac output. Will not increase; it will remain the same. Now let me explain for the basis of this MCQ. First, the logic. Why the cardiac output will not increase even if heart rate is increasing? I'll first explain the logic behind it and the mechanism. Logic is, in isometric exercise, there is sustained tension development in the group of muscles. Imagine when cardiac output increases in any condition situation. That increased cardiac output means that increased blood flow is going to some tissue. Some tissue is demanding extra blood. Therefore, cardiac output increases. In the case of exercise, which tissue is demanding extra blood? It's the skeletal muscle, which is contracting during exercise. It is demanding extra blood. And the same muscle, or the group of muscles, which are demanding extra blood flow because they are contracting, they will need extra blood flow. They themselves are having a sustained contraction. That means sustained compression of their own blood vessels. So they are not allowing their own blood vessels to open up and get that extra blood flow. So even if cardiac output increases, where will it go? Because muscle which is demanding extra cardiac output, extra blood flow, itself is not allowing that blood flow to happen, extra blood flow to happen because of the sustained contraction. That's the logic. Therefore, increased cardiac output logically also doesn't suit, is not looking appropriate. Second thing, what is the mechanism? Even if heart rate increases, stroke volume will decrease, and therefore cardiac output will remain the same. It will not increase because if there is a sustained contraction of the muscle, then there is a sustained compression of the blood vessel inside it. That means the blood coming in per unit time will also decrease, and the blood going out and blood returning to the heart, that is venous return to the heart, will also decrease over a period of time. Blood coming in per unit time will decrease, blood going out and venous return to the heart will also decrease. Decrease venous return, decrease stroke volume. So heart rate increases, stroke volume decreases, cardiac output will remain more or less the same. These are the changes in isotonic and isometric exercises, cardiovascular changes.